Hey guys, welcome back to this course. In this particular topic, we are actually going to be creating Felix Candela's shell structure, which is Los Manantiales. Now, as you can see over here in the Rhino viewport, you can actually see what we are about to create using this particular Grasshopper script. We'll create the script from scratch. Let's see what we can do with the script in the first place. So you can actually increase and decrease the size of this particular structure. Just like this. It's totally parametric, so everything changes with this one slider. You can also create and change the number of folds that you have, so you increase or decrease it. You can have the structure with 4 folds or 8 folds or 10 folds depending on what you actually want. You can also go ahead and change the curvatures of all of these things. So for example, if I want to change the top curvature, you can do something like this. You can change the tangent controls to something like this. You can make them sharper, you can make them broader. You can also do it for the bottom. You can also go ahead and change these things right here, these edges. And you also have a lot of other controls that you can apply and change the curvature of this entire form and create the structure according to what you actually want. You also have the total height of this whole thing. So if I play around with the top ridge, you can also control these kinds of shapes, that you actually can control using these number sliders right here. And at the end of it all, you basically create the thickness of the shell, and you can also control that using this particular number slider. So all of these things are editable and changeable, and we'll actually take a look at how to do all of these things in this particular script. So let's start fresh and let's start creating Felix Candela's shell structure in Grasshopper. So I'll just go to file and create a new document, and we can directly start with our script. So the first thing that we are going to do is we are going to create a circle, and based on that circle we'll actually divide it up using the perp frames component and then create the NURBS curve according to those particular points. So let's start by creating a circle first. You can just double click and type circle. Bring in the circle component. It asks for two things, plane and the radius. Plane can be based on a point that you input so that you can control the point around and move the structure wherever you want to. So you can just double click point and type point and bring this in and attach it to plane. You can right click on point, click on set one point and set the point right here. You can make sure you have grid snap on so that you place it right at the center. And now you have your circle right at the center of this. Now you can just attach a radius to something like 50. Let's attach this, and there we go. We have our circle right here. Now let's go ahead and create the perp frames that we need on all the sides. So you can just double click and type perp frames. Have the perp frames component. Bring this in. You can actually find it in the curve component under division. Let's attach circle to curve, and there you go. You have attached the curve that you actually want to create perp frames on, and it's creating perpendicular frames on your circle. Now you can also change the count of this, but according to the count, the number of folds that will appear on each of our structures will actually change. So let's create a multiplication factor and attach it to count so that we can parametrically control it. So you can double click and type multiplication. Bring in the multiplication component and double click and type panel. Create a panel. Make sure you don't have this written on top of it. It's not necessary. You can just delete this, and you can double click and type 4. Click outside so that you have 4 divisions at least, and you can just use a number slider, say 4, attach it to A. So you have these many counts and you have these many frames. So if you keep on changing this, see how these things change. So it will always be in a factor of 4, it will always be multiplied by 4, so that you have those number of folds. So after you're done with this, you can actually dispatch these frames into alternate lists. So we have this one and this one and this one and this one. All of these alternate frames we can have in one single list, and the other ones we can have in another list. So we can use the dispatch component for this. We have seen the dispatch component in the previous topic. So you can just double click and type dispatch, bring in the dispatch component, attach frames to list, and now we can just turn this list A and list B, we can just plug them inside separate surfaces. So you can just double click and just type plane and bring in the plane component. You can actually input planes over here because these are not surfaces, these are planes. So you can just copy this. So list and list, these are the two lists of planes. So now as you can see on the screen, you select this, alternate planes have been placed inside one list, which is list A, and the other planes have been placed inside list B. So once you're done with this, now what we can do next is we can actually deconstruct these planes. We have seen deconstruct planes in the previous topics. We have explained and we have understood what deconstruct planes actually do. So let's use it over here. You can double click and type deconstruct plane and bring in this deconstruct plane, and you can copy this because we need to deconstruct both of these planes. So if you deconstruct a plane, it will give you three things. It will give you the origin, which means the center of it, this point right here. It will give you the x, y and z axis. It will give you the directions, and along with those directions you can actually attach number sliders and multiplication factors and division factors, and you can actually control those values. So let's go ahead and do that. So I'll just attach this to plane and this to plane, and now I have actually deconstructed these planes separately, and as you can see I am able to select alternate points and these ones separately. So I'll just go ahead and turn everything else off, and I'll just turn the circle on so that I can actually see which point is which. Now I have these two alternate sets of points and deconstructed plane values. So let's start with the first one. We can actually create set of top points. So we can do that using the move tool. So you can just double click and type move. Let's move all of these points, these ones, the z-axis. So you can just double click and type multiplication, bring in the multiplication component, and inside one of these you'll have to actually attach the axis that you actually want to move it to. Now let's take a look at the axis first. So I'll turn this planes on, and if you zoom in and if you see, the z-axis is not the z-axis, it's actually the y-axis. All of these planes have their y-axis in the z direction. So this y-axis is actually giving you the z vector. So one of this will actually be attached in A and the other one can be controlled by a number slider. So you can just double click and type something like 24, and let's move all of these over here, and I'll attach 24 to B, so that now if you plug this inside motion and plug origin, which are these points, inside geometry, and you suddenly see that all of these points can be now moved in the z-axis. Because the z-axis is actually the y-axis for these planes. We have broken down these planes, so the y-axis of these planes are the direction that we need to move these points around. So you can actually control the magnitude using the number slider. Let's change it to 24. So after you have done this, now what we can actually do is we can create another tangent control using the z-axis, So let's double click and type multiplication, bring in the multiplication component. You can copy this number slider right from here, change it to a value of maybe 9, keep it on B, and now plug the Z inside A. Now why did I plug Z inside A? I'll come to that, because you have to understand that the Z for these planes are either this direction or this direction. So why did I do that? We'll actually come to that when we actually join all of these things together. But for now, you can just go ahead and repeat whatever I'm doing over here. We'll understand the logic once this entire setup is complete. So once you're done with this, now you can actually copy this whole setup once more by using Alt. You can actually disconnect all these things. You can just right click on geometry, disconnect this, right click on A, disconnect this, and now let's attach some other points and let's understand what else we have to do. Now we also have to move these points in the z-axis like we moved these points. So origin goes to geometry, and inside A we'll actually move, we'll actually attach the x-axis of these things, because you need to understand, if I turn on the planes over here, we're actually moving these particular points not in the z-axis but in this direction, and this direction is the red line, which means the x-axis. So the x-axis will actually go right over here. Now as you can see, we are able to move these points in this direction. See, like this. So make sure you keep it at something like 9. Change this to 9, click on OK. Alright, now once we are done with this particular thing, now let's go ahead and create the set of bottom points for this. So you can just put this over here.